Yes, come. You can come through. Gert.
I'm Gert. We, with Andrew and we're working on the house bot. Planning to build a little robot for the House4Hack. Don't have a funky presentation yet, but maybe next time. We're still throwing a lot of ideas around, but the plan is to have a little house robot that's going to wander around here, take pictures, go where people are, follow sound, and just generally make a nuisance of itself. Yeah, so we'll see. We're still throwing ideas around. I think the one thing we've decided on, the best would be to have it attract a vehicle. It's more stable, it's easier to turn and so on. Yeah, one requirement is that it must be able to climb stairs up and down, because we've got a couple of steps in the House4Hack. We're planning an arm on it to fetch things, bring in a cool drink or something at some point. Yeah, so anybody who wants to pitch in and give ideas, welcome.
How far along are you?
We've decided so far to concentrate on the basic platform, to get something on the motors, just get something working. I think the first step is, I think the idea has evolved now to build a generic motor driver sensor PC board, which can interface via I2C or SPI to any microcontroller, so that it's not just limited to our robot, but that anybody who wants to build something with motors and sensors and feedback can use that. I think that's a nice idea. Yeah, so that's basically where we are at the moment.
Nice.
Right.
What do you hope to get out at the end of the day?
Oh, yeah, to have a little robot and have a lot of fun. I mean, yeah, we can all, yeah, I suppose anybody can do this, but you always talk about building a little robot, nobody ever gets around to it. So working in a team with the hackerspace, it's an excellent opportunity to have fun and actually get around to doing it.
So you're going to actually build a platform that will move around and stuff too?
Today?
Yeah.
No.
What do you think will happen by the end of today?
No, I think by the end of the day we'll decide, yeah, I think we've decided now to concentrate on the motor driver PC board.
So perhaps if we're lucky, we might have a circuit diagram, or at least a block diagram of the circuit.
Yeah, no, I think we'll work on the block diagram.
They're going to try and build some of it.
Yeah. Well, we're going to order the components. We're actually still working on the bill of materials.
Okay.
So we're a little bit behind. We won't have a deliverable, physical deliverable, but we'll have something today. But this is a longer-term project.
Yeah, no, it's quite a long-term project. Yeah, so the ARM is a whole project in itself. To have the ARM will have to help different climb the steps. But yeah, so I think the first phase is a one-level robot, and we'll just see how we can manage it to climb stairs and so on.
Are you planning to use compressed air or?
For the motors or the ARM?
Yeah, the ARM side, because they generally a bit more power.
Yeah,
I mean, we spoke about pneumatics, but we haven't made a decision on the ARM. And in fact, we probably see that we might have multiple sub-teams working on different components, because
If you just get into sort of the hand side of things, it can get a bit complicated.
I mean, you can buy off-the-shelf electric motorized ARM, but we don't really want to do that. We want to actually explore the whole dynamic of the ARM. But I think before we, our focus at the moment is just on the base platform, almost like the primitive. We want to get some motion, and we want to work on the primitive brain, and then, so work in layers.
Yes.
But I saw this one project that I think is very nice. It's what they use with the servos. The servos essentially is the motor and a resistor. Okay. So then what you do is you open the servo and you connect the wire.
Yes.
Have you seen that one?
Yes, I have. So you can move it, becomes a sensor.
Yes.
Yeah.
And then you record that motion.
Motion. Yes.
So the idea is that if you've got complex arm movements, then you like just move this arm in a certain way, and then you like record, and then afterwards you can just play back, and it becomes like put arm there,
Nice.
close, whatever, pick up something.
I like
Just
it.
takes your programming, just take a lot of the pain.
It's very clever actually. It's almost like breaking language down into phonetics.
Yeah.
So you've got these like little snippets that you can string together
That's
to
right.
make complex
So
movements.
you can have like primitive instructions.
That's-
Yeah.
The thing about the hydraulics, it does give you more power. And I mean, even in nature, if you look at a spider's nervous system, I don't know which way around it is, but I think, for example, a spider can only pull its legs in using its nervous system. And then it pushes them out with blood, with hydraulics.
Mm.
So they use a common, so it's not this, and I mean, the spider's leg's quite complex and whatever.
Mm.
So the combination of hydraulics and electrical driving might be your thing to explore. So yeah, if anyone wants to get involved in the ARM sub-project, go for it. We're ready.
I was just thinking about CO2 for some reason. There's a hell of a lot of power at a very small weight. And you can get quite good actuation, but then the issue is just about valving.
Yeah, and replenishment.
Yeah, I was thinking more
For it to be autonomous, it's easy to go and charge itself again. When we were thinking about the hydraulics, we were thinking about water puddles all over the house, and that didn't really excite us. Or
Like
oil
you're
pumps.
getting a new puppy.
House trainers.
Anyway,
Oh, what's house training?
the project is open. One thing that's missing is we don't have a good name for the robot. So I'll put it out there on the web. Give us a name. Yeah, because I mean, Housepot, it's quaint, but and we already see it's going to have a helicopter friend. Maybe with a little bit of infrared temptation, it'll follow it all over the house.
Send the heli for assistance.
Okay, that's the project. Thank you.